Welcome, friends. Event loop lag. Anybody have any clue what this is?
I do, because you explained it earlier.
Right. AJ does, because AJ and I worked together and I was trying concepts on him, asking for help, desperately seeking help. Stetson knows what I'm talking about. I can't remember your name, but Todd knows what I'm talking about. I ran into this when I was working at Ask 2 or 3 years ago. We started up a Node project because we were a bunch of JavaScript engineers who were sick of writing Java, and it was awesome until we were processing 10 requests per second in our Node process and trying to figure out why. And so we began to explore event loop lag. How many of you are gamers? What's lag in gaming?
Awful.
Death. What happens? You're sending commands to your computer. Those commands are not getting to the server, at least not in time to save you from being shot by the other guy, or whatever it might be, right? Lag means things are going slowly. The message is not getting through when I need it to get through. That's what's happening with event loop lag. Who knows what an event loop is? All right. Jake, tell me what an event loop is.
Is this like some weird like STEM engineering version of like event loop, or are we just talking like for ifs and for eaches here? I guess I don't know what an event loop is.
Event loop, can I bring up that picture more easily? Can you see that picture well enough? We can see this picture well enough. The JavaScript event loop, massively simplified, is a function stack. What is a function stack? When I start up my program, I'm starting a function. That function calls other functions. Every function it calls adds a layer to the stack. I call another function, I add a layer to the stack. I'm building this nifty little layer cake here. When I'm done with my function, I return from that function, I go back down my stack, pop that level off the stack until I get to nothing left on the stack. So JavaScript, when it starts up, the first thing it does is it starts up that stack. Now, it actually could start any place in this loop here and it would probably be just fine, but we'll pretend that that's what it does. It starts up the stack, it runs through it, it runs to that stack to completion, doesn't let anything interrupt it, ignoring the other things that might actually possibly happen. Go read Mozilla about that. I'm not going into that. But starts that stack, goes through that stack, gets to the end of that stack, and then what does it do? Well, if it's Node, well, here's what's going on. There's an event loop right there in the middle where my pointer from my mouse is pointing at the little loopy thing. And that loop says, hey, have I got any other functions waiting on this queue? These functions here, they're not running yet. They're functions that are scheduled to run for some reason. Now maybe they're scheduled to run because they're the first function. Maybe they're scheduled to run because a event took place, like someone did a set timeout and said after a certain amount of time, schedule this function to run. Maybe you did a file system read, or you called an HTTP API or something like that, did a network call. And those I/O events had a callback, and that callback scheduled something on the queue to get done. So we got done with our stack. The event loop in the middle here says, I'm done working, what do I do? Oh, I know, I'll go check the queue and see if there's anything else for me to do. Pulls this first function, puts it on the stack, runs it to completion. When it gets done, it's an event loop. What does it do? It looks for another event to run. Now, there's an important thing about this loop. When you're running your stack, you can schedule other things to happen into that queue. How do you do that? Well, I've got clues here for event timers, callbacks, and we kind of talked about those things. By the way, all of those things that schedule those things on the event loop are things that functional programmers will say are impure side effects, and that's why JavaScript is only a functional-like language. I love it. I don't care. All right. quick and dirty description in code of what the event loop looks like. This is not how it's implemented. This is sort of JavaScript-esque. The event loop for most JavaScript engines is actually written in C or C++. But the idea is you've got a queue. We represent that with an array. We've got a whole bunch of things that we're holding on to. Timers, callbacks that have been scheduled to fire, streams that we might be listening for events on, a bunch of references that will keep Node running and keep the event loop looking to see, hey, did something get scheduled? Because if nothing is scheduled and nothing's on the queue, Node says, all right, I'm done, and it quits. All right, and then this is the actual loop. While true, many event loops look a whole lot like while true, and they have some condition where you break out of the loop. JavaScript, usually you don't write while true because it's really hard to break out of a loop when nothing can get into your execution stack. Another reason is don't do that. Don't do that. This is pseudocode. But we're going to pull things off our event queue right at the beginning. We get the function, and if that's a function, we're going to run it. That's what the event loop does. All right, so we talked about the stack. Pull a function off the queue, start up a new execution stack, we run it. The stack, we'll probably call other functions, adding layers to the stack. We talked about this. We can schedule other things. The stack may schedule other things to happen through timers, async IO, promises, event listeners, etc. And flame charts. Flame charts are really interesting things, just sort of a reference. There's ways to get to track, to debug your Node app over time so you can see what that stack looks like. And a flame chart basically takes the stacks over time, puts them next to each other, and then gives them a nice yellow to red gradient, so it looks like your app is burning as the stack gets bigger and smaller. And the reason that's interesting is it helps you to see where you're spending time in your event loop. Okay, but that's not, well, actually that isn't relevant to event loop lag. If you have lag, you may find you're spending a lot of time, your flames are really big in particular functions. While the stack is running, the queue just stands in line. That was a lot funnier to me than apparently it is to you. All right, so functions don't go into the queue until they're ready to run, at least conceptually. Event loop lag, talking about a measure of how long a function had to wait in the queue to run. We scheduled it to run. You had a doctor's appointment at 10 a.m. It was 10:15 when you finally got to go in to see the doctor. That 15 minutes is the event loop lag between your scheduled time and the actual time that you got to do your thing. Sample code. This code was written pretty quickly. That's not the code. This is the code. Okay. We put together an event emitter. That event emitter is just simply so that we can run this console log that's down. Well, yeah. So we can emit this event, and we can log that we have. Oh, here it is down here. That we scheduled to a log after a given number of nanoseconds, and it actually took a certain number of nanoseconds to run, and then the lag is how late that we are, how long it took minus how long we expected it to take. Any questions about this code? It's pretty simple, although it took me longer to write than I thought it might. That code, when it runs, looks a little bit like this. It's set up so that it'll take process argv2. It'll default, this is how high we're going to count. One of the things that'll cause the event loop to lag is we just spend a lot of time doing something. So because I couldn't come up with a better example of this, we're just going to count to a really large number. Counting to a large number in the loop as long as we're actually doing something in the loop and it doesn't get optimized away, will prevent the event loop from moving on to the next thing. So we're going to say, we're going to count to a large number, our count target, and we're going to have an interval that basically says how long we're going to set a timeout that schedules a log to happen. And we're going to see how late our count makes our interval. So here I've got 300,000. I told it to log only like 1/10 of the time as it's counting so that we don't just fill up things. So this looks a little bit like this. So someone tell me what we're seeing here. Observations from the logs.
Pretty consistent.
Oh, is the CPU being shared in chunks?
No, so this is the reason that you see the 30,000, 60,000, 120,000 is I literally said take every time we count to a number that is modulus 0 of, or it's modulus the 1/10 of the total number. So if I did 300,000 here, so every time you get to a 30,000 and your modulus is 0, we're going to log it. And that's just so I didn't log 300,000 numbers up here on the screen. But scheduled log at, what is that, 200, no, let's see, 1,000, 200 million nanoseconds, but it took us 296 million and change nanoseconds to get there, which means we were 96 million and change nanoseconds late. Okay? This, the amount that we're late, that's event loop lag. That's the amount of time that you scheduled to do something, but it couldn't happen yet because the doctor was busy with the previous patient. That's the concept of event loop lag. Any questions?
Can you click back into the code real quick?
Into the code, yes.
Okay. Just wanted to see
The setup?
the set timeout.
Oh, okay.
I didn't have a question, I just wanted to.
You wanted to see the set timeout here. We're saying set timeout, run after the interval. I'm deliberately not using a set interval here because that would cumulatively grow, and it would be a more challenging thing to set up to demonstrate what we're doing. In this case, I'm saying the interval is 200 milliseconds, and I'm having to translate that into nanoseconds, which is what this nanoseconds per second divided by 1,000 times the interval is. And then I'm using process HR time. Process HR time is, who knows what how date.now works? Unix time, which is milliseconds, right? So it's milliseconds since Unix epoch, January 1st, 1970. Process HR time doesn't have an epoch, or at least not a consistent epoch. So what you do, it gives you high resolution time in nanoseconds from a start time to another time. So you can get a difference in time, but you can't relate that back to a system time of any sort. So we're using that because sometimes your lag is actually in nanoseconds and you can't really tell how big it is. And in fact, hopefully your lag is in nanoseconds because you've scheduled very few blocking things. If you've done that well and you have this sort of a measure in your code, you should see very small numbers for your lag. Is that making any sense? I'm getting a couple quizzical looks out there.
I'm just thinking, like, how do we fix it? Or how do we...
Well, let's talk about identifying it first. What are the causes of event loop lag? So, what causes lag? Hey. Obviously a long count. Anything that causes your stack to just not return for a long time will cause lag. AJ.
I want to bring up the example we were talking about earlier.
Yeah.
I think it's really relevant. So here he's showing counting numbers. That doesn't really introduce lag. Things in other languages like Python, Ruby, Go, etc., like reading from the file system that would cause lag in Node go into the event queue. One thing that causes lag in Node that people will run into is JSON.parse and JSON.stringify. If you're doing a very small config file, it's going to take relatively no time. If you are actually going out and fetching from some API service, say 100 kilobytes of JSON, so blog articles, for example, Zendesk, that sort of thing, you will actually completely halt your node process during the time that JSON.parse is executing. Likewise, when you call in Express res.send, and you send an object from your database, if you're sending an object from your database that has 1,000 or 10,000 or 100,000 items in it, you will have actual lag time where nothing can connect to your node service.
So, blocking functions, he mentioned, reading from the file system synchronously. This is something that will cause lag time. Why? Because it literally stops the event loop and says, in fact, it stops your function right there at that equal sign effectively and says, we're not going to do anything more until the operating system is ready to deliver data to us. And so your node process will sit there pinned at 100% CPU waiting and waiting and waiting until that file sends you data back. Now, most of the time, that's not that big a deal because we're talking about milliseconds, and it's actually faster to read files synchronously than it is to read them asynchronously, if you can afford to block. So at startup, if you can afford to block for a few milliseconds, this is faster. But if you're in the middle of your runtime, you may not be able to afford to block, and that can be a very bad thing. And so most of the file system stuff have their base functions don't have that sync on them. Don't say sync here. You use fs read file, and that's wrong. It's not read sync, it's read file sync is the one I was trying to demonstrate. But they'd say fs read file, not fs read file sync here, so that you don't block. And you do that so that your event loop can keep processing other things. More blocking functions. Where's the function here? Require is a function here. Require synchronously reads off the file system. And this is a clue to what AJ was saying is a clue to what's going on here. If I pull a JSON file, and it's a big JSON file, and I pull it in through require is going to implicitly do a JSON parse on that. And my event loop will stop effectively. Synchronous functions like JSON stringify.
Oh, you already had it. I wasted my time.
No. You gave a great.
Really good thing.
I loved your description of it, AJ. It was awesome, and I really, really hope the film picked up that if you're talking about downloading a bunch of JSON and parsing it, or you're talking about sending a bunch of JSON, stringifying it, both of those are operations that can block your event loop and prevent your process from handling other requests. Will?
Is it worth it, or does this already exist, to have a library that parses JSON asynchronously?
Such functions do exist. There is a JSON object stream module that's been around for years that's great for parsing a very large JSON object in small chunks that can go quickly and allow the event loop to keep working. Corey?
I was going to comment on that. I'm sure there are legitimate reasons that you would want to do that. I have never run into one. It's usually a symptom that you're doing, that you could be doing something in a better way, rather than I have to parse this ginormous thing, so I better parse it asynchronously.
So there are multiple reasons why you might do a streaming parser. For instance, while I was at Ask, one of my coworkers needed to download some XML data from Amazon. I don't remember what it was about, but it was something like 8 megabytes of data. And every time he would run his Node script, it would crash. And the reason for that was he'd run out of memory while it was trying to deal with the hairy process of pulling apart, just getting all that XML into his parser.
Like I can see why, like what you would say, you know, like he's never found a reason to do that, because usually the purpose of importing JSON is to want data. Yeah. And the next statement is probably going to be using that data. So, I mean, I don't know. I mean, I guess if you like import it asynchronously and then like in a promise, like then you use that data, but.
So if you import through if you're importing through a streaming parser, one of the things you might do, you might select just little bits of data out of that big JSON stream. So you might bring it in and say, okay, I only want one object at a time, and I'm going to determine, am I going to keep this object, or am I going to grab just this little bit of that object and throw away the rest of it? At which point you're taking data that you couldn't fit all of it in memory, pull it in a little bit at a time, and you just select out of it pieces that you need that you can fit in memory. And you might run that through a pipeline and so forth. Stetson, did you have a comment?
There is a Express competitor called Fastify that is built to be async first, and they actually have an equivalent to a JSON parser that does stringify and parse for you, but you have to know your schema of the actual object ahead of time, and it prevents a lot of stuff like this. I was going to go find it, but
We mentioned JSON parse already. Process.send. This is another example where if you are using child processes in Node, so one of the things that you might do in Node to try to mitigate this problem of, gosh, JSON stringify and JSON parse are expensive, maybe I'll just ship this object off to another process and let it work there. Well, unfortunately, process.send, which ships that object off to another process, does a JSON stringify, sends it to the other process, and does a JSON parse. So now you have two processes that are blocked. This is one of the things you just need to read the docs and be aware kind of how these things are working. So this is a lightning talk. I haven't gone into all the reasons why this might happen. The example of what was going on at Ask that was really interesting, we had a fairly interesting config object, and it was a layered configuration object. We would get a config off of the file system, and then we would get an additional config via some APIs that would help us to determine what A/B test we were going to drop a user into, and therefore what modules we were going to load. Well, we're trying to figure out what's going on with this. We put a console debug, a logger debug statement in there. And then we had JSON.stringify config in that logger debug. And we thought, you know what? In production, we're going to just turn that off. Our log level's tuned up to warn. That won't even run. No big deal. Who can tell me the problem? From the verbal description I just gave you. Let me see if I can show it to you in code. That line.
You've still called the big slow function. You're just not actually outputting the result to the console.
That's exactly what was going on here. We were busily creating a big log stream with that JSON.stringify, and that config object was pretty big. And oh, by the way, this was running not just once every request, it was running multiple times a request while we were putting everything together and building it up and merging that config and then building up the list of modules that we were going to use to render the page. So what happened? When we deleted that line, immediate 10% improvement in performance. Just deleting the one line there, getting rid of that console log, because we weren't blocking our event loop. One of the next things that we did, we implemented a measure of event loop lag in our code. so that we could see where it looked like we were slowing ourselves down. AJ.
Also, console.log itself is the same as fs.sync_write/dev/tty or /dev. It is a file descriptor write that is synchronous.
Right.
So just any console log at all actually blocks your node process.
That's a great point. A console log will also block your node process because it's going to synchronously take whatever you told it to write and write it to the stream and wait for the operating system to say, yeah, I wrote that, it's safe. Now, we were using a different logger at the time that wrote to files and some other stuff, which maybe was better.
It's all the same. It's all file descriptors.
Right.
Unless you're using some sort of like system, whatever they call logd, like unless you're doing some sort of logd plugin or something like that, you're synchronously running.
Right, so you have to make sure that and there's, when you look at the console log and process.standardout and some of these things, when you look at that documentation, it'll talk about this. These things will block. Be careful what you log, be careful what you write to them. It's something that you want to be aware of as you're looking through your code. Where am I doing things that slow it down? Where am I parsing JSON that you want to know what? I don't have to parse this JSON. I can just pass it on. Or other things like that. Where can I use a cached version of this thing? There are lots of ways to mitigate event loop lag. You'll want to, if you're experiencing a performance problem, profiling a performance problem is a whole other talk that I'm not really all that great at giving. You'll want to identify through profiling how you're actually, where you're actually blocking your process. That's where the flame graphs and other things come in. They're ways of visualizing where you're getting stuck, where you're having that problem. So if you can identify that you have a problem and then identify where you have a problem, these things will help you. These are some clues as to how to address that. Any other thoughts or comments? Thank you for your time.